Hello, everyone. Welcome to the fifth lecture on fundamentals of C++ programming. I'm Mortaza. Today, we are going to talk about memory and data storage, pointers, and reference. In the previous lectures, we talked about machine code, decompiling, and scripting languages, their difference. We talked about the building blocks or elements of code, and C++, particularly. We talked about compiling and linking. We said that there are compiling and linking processes where we may have errors related to compiling and linking. We can identify the errors in compiling using the Visual Studio and any integrated development environment. However, finding the linker errors is a bit difficult since it's not visible, and we have to go through the object files and find the errors, particularly if we have, for example, a defined function and we haven't used the function, we might have errors. We also talked about one definition rule, say that variables, functions, and classes should be defined only once. And we talked about declarations. We say that we divide our codes into files. One is header file, and the second is source file or CPP file. In the header file, we mainly declare variables and classes as well as functions. Sometimes we can initialize variables. However, in the source files, we implement the functions, and we only have one main function in each project. We can have multiple header files and source files, and we include header files in the source files. We talked about the two main components of declarations, the data type, as well as the identifiers. We say that there are rules related to the identifiers. We have to use data types in C++, and the built-in data types are voids, integers, doubles, bool, and we can initialize variables in the header files, and it's optional. We encourage you to initialize your variables. We talk about expressions. In the expressions, we say that an expression consists of operands and operators. The operators are like arithmetic, logical, and different kinds of operators, such as equal, plus, minus. However, the operands are mainly the variable names. For example, if we have A equals to B, A and B are operands, and the equal sign is the operator. We talked about statements, the selection statements or conditional statements, where we use if statements, and in if statements we may have else if and else. They are optional, and we can have multiple else if statements. We also talked about loop statements. We call it iteration statements, and mainly we have while and for loops. We can use bricks and continue. We also talked about functions, and we defined the functions in C++ and compared it with mathematical function, and we said they are similar. However, they are demonstrated in different way in C++. We talked about function overloading and say that functions can have same name, same data type, however, with different argument types. We talk about arrays, say that arrays are fixed in size, and the size can be determined at the compiling time. We cannot change the size of arrays in the running time. Talked about vectors and said that the vectors size can be determined at the runtime. So there is flexibility. We brought many examples and assignments for you, and I hope you have done the assignments. If you still have any questions related to the last lectures and topics, you can send me messages directly and I will answer your questions. In this lecture, we are going to talk about memory, pointers, and reference, and how we use pointers and reference in C++. The next lectures are classes and objects. If you are interested in this, okay, let's go to the memory and data storage. What is memory and how we can store data in the computer? Well, computer memory can be imagined as a long row of numbered Hausser slots where each unit stores 1 byte of data. Each unit has unique address, and the number of slots a variable occupies depends on the type of data. So we may have integers, doubles, char, and bool, or sometimes we have void. This type of data has unique capacity and unique size. The number of slots a variable occupies depends on this type of data. For example, if we have a char variable, it occupies 1 byte. However, if we have a double variable, it occupies 8 bytes. The address of each unit can be revealed by a reference operator. So when we use the reference operator that we will talk about it later, it gives us the address of the unit that the variable occupies. And the location of address to a variable is dynamically allocated. And the variable is actually a container that holds the data, and it is usually on the left side of the operator. We call it L value. And the value assigned to the variable is called R value, and it's usually on the right side. The L value can be located on both sides of the operator. However, the R value cannot be located on the left side of the operator. It's always on the right side. For example, if we have A equals to B and B equals to 5, the number 5 is the R value, and it's always on the right side. However, A and B, it can be on both sides of the operator as A equals to B, and they are called L value. Let's go to the memory layout in C++. Well, there are mainly 4 sections of memory. In the code section is the executable code after linking the object files and turning them to one executable file. This could go to the code section. However, the data section is the initial data, and they are called also global and static variables. They are loaded to the memory at a startup, and they are deallocated from the memory when the program finishes. However, the code section is loaded automatically by the operating system and unloaded by the operating system as well. The heap part of the memory is called the dynamic memory, and it is general purpose memory. So data can be located contiguously. When we want to allocate data to the heap section of the memory, we use the keyword new. We write type of data, and using pointer, it equals to new type. When we use these keywords, we actually allocate memory for a variable in the heap part of the memory. And if you want to deallocate and remove this from the heap section, we use delete pointer. On top of it, we have a stack where the local variables are located, and they are automatically located in the stack continuously. And with the rule last in, first out, the data can be deallocated from the memory automatically. It's worth to remember that the heap section of the memory can grow up and down, so it's very flexible. You can, if you need a lot of memory and data to be reserved in the memory, you would better to use the heap section of the memory. The bottom section, mainly the code section, is called low memory address. However, the stack part is called high memory address. You need to understand three very important phrases. The data allocation means that when we allocate a space in the memory for a variable, we mainly assign a value for a variable. It's called data allocation. When we remove the data from the memory and reclaim the space, it's called deallocation. And when we assign an initial value for a variable, it is called initialization. Okay, we have virtual and physical memory. The physical memory is mainly the RAM, or random access memory, and it's usually small, and it has page frames. However, the virtual memory is big, and it is built by the operating system. In reality, we have multiple programs that are executed simultaneously. So how this is possible? Well, the operating system assigns addresses in the virtual memory of the computer for each program, and these virtual addresses are then converted to physical address. There is a mapping process where the addresses from the virtual memory are converted to the physical address by the memory management unit. And the memory management unit is a hardware component of the computer, which maps the addresses from each program to separate areas in the memory. And also, we have a backing storage or hard drive, since the RAM is not enough for storing large data. So this can be then stored to the hard drive or backing storage of the computer. So we have C++ file or an executable file, and this goes to different sections of the virtual memory, and then it goes to the physical memory. Okay, let's get to the pointers. Pointers are variables, very important. Pointers are variables that store the memory address of other variables which are assigned to pointers. And the way we declare pointers are similar to other variables. Only difference is that we use the character store and it is attached to the data type. For example, if we have double star A, the double is the data type, star is the pointer declarator, and the identifier is A. So we can declare the pointer similar to other variables. However, the data type of the pointer must be the same as the type of the variable that is pointing to. So we have a variable which is declared and it has an address in the memory. The pointer that points to that variable is mainly initialized with the address of the variable. We will explain this with example in the next slide. And the address of a variable is the first byte of the variable. Say that variable size in the memory depends on the type of the variable. For example, if it is integer, it has 4 bytes. If it is double, it stores 8 bytes. However, the address of the variable in the memory is the address of the first byte. So if there is a double type of 8 bytes, and if you want to reveal the address of the variable using the pointers, it reveals the first byte address. And the pointers are initialized with the address of variable using the AND operator. Variable initialized reveals the address of variable it is pointing to, however, by using a difference operator before the pointer variable, which reveals the value of the variable the pointer points to. So we have L value and R value. If you want to reveal the R value of a variable after pointing to the variable's address, we can use the difference operator, which is the same as the pointer operator. It reveals the value of the operator. Let's go to the example where we use pointer and open the Visual Studio. Let's start from the very beginning. For example, we include history. We include CMIT. And in the header file, we declare, for example, tuple A and initialize it with the volume of 5. And tuple, when we declare pointer, we say after the data type, we use the star operator or the pointer operator, and then we call it pointer variable name, and we initialize it with the address of the variable a, and this a pointer points to the address of the a in the memory. Now we go to the main CPP or source file, and here we say include the pointer.hpp, and we have a main function. In the main function, once we to make life easier, we will talk about namespace later in the lecture 7. Using namespace std, we can shorten the cin and cout. So we call it cout. Instead of writing std blah blah and cout, we use short cout. And we say a equals to a. In line. So what do we expect from this function? It must reveal the value assigned to variable a. How about if we declare the a pointer? Well, that must give us the address of the variable a, because it is initialized with the address of a. Yes, we run the code, and we run successfully. You see the value a, the variable a equals to 5 because we had initialized with 5. And the a pointer is a variable that gives the address of the variable a. I have to put a sign here. Let's go to code. And one thing we also say that we can use the reference operator. So the reference pointer. If we use the difference operator, which is star in front of the a pointer, it gives us the value of a. And let's see. We run the code, and now we go to the result. You see that a equals to 5, and a pointer, which is pointing to the address of variable a, equals to an address in the memory, and the difference pointer, a pointer, equals to 5. It is exactly the same as the a. We use the difference operator, and it gave us the value of variable a. So this function gives us value, gives initial value of A. This function gives us, or it reveals, the address of A because it is pointing to the address of that variable. And this function, the value of A. So A, and dereference A pointer equals to A. A. Okay, now we go to the pointer and memory. We said that the pointers reveals the address of variable that it is pointing to. And let's go to the address, say the memory. We said that the memories can be imagined like a long row of slots or houses with numbers. This is an example of the memory. For example, we have slots in the memory, like 220, 131, 32, 33, the same as the address of houses in a street. And when we assign, initialize integer A with number 11, integer is actually determines how many slots or how many units of space the variable A occupies. So it is integer, and we say that integer occupies 4 bytes. Each address in the memory has 1 byte capacity, and integer A occupies 4 slots. So the value 11 is an integer and it occupies 4 slots in the memory. However, when we initialize the address of A in the memory with the pointer, A pointer points to the first byte of the integer A. So when we use the pointer operator, it gives us the address of the first byte of integer A. 230 is the value of the pointer. A pointer, however, in the memory occupies 8 bytes space in 64-byte operating system. We can also use the size of operator, and it gives us the number of bytes a variable takes. We go to the pointer arithmetic, which means that we can add and subtract pointers in the memory. And pointer arithmetic is mainly used for arrays because they have the same data type. All variables have the same data type. So elements of array occupy consecutive address in the memory. And therefore, using pointer and the arithmetic operators, we can reveal the address of different elements of a variable. We can use the increment, decrement, plus, minus, equal operators to move the pointer along the orders of the data type in the memory, but we cannot use the other variables, other operators such as the star equal and division equal. Adding and subtracting a number from pointers always changes the address by this number. For example, if it is 1 times the size of the element, if it is integer, it is multiplied with 4. If it is double, it's multiplied by 8. So an array is decayed to a pointer to its first element that it is initialized with. When we pass arrays to functions, it doesn't give us the elements of the array. It is decay to the first element address. And pointers can be passed to functions as arguments. So therefore, when pointers are passed to functions, their data is passed by reference. Therefore, the functions operates on the original value. Now we go to example pointer arithmetic. We have an array, and we use the pointer arithmetic to reveal the address of each element in the array. Now I go to Visual Studio. Okay, for example, we have just to make it quicker, integer A, array A, 2, 1, 2, 3, 4, 5. So this is an array, and we can initialize it we have 5 elements. So this is an array called A, and say that the pointers must have the same data type. So for example, we say A pointer equals to the address A. However, it's not possible because the array has 5 elements. So we can say that with the first element address, first element is 1. Now we go to the to the main function. Now we don't have an integer, we have arrays of integer. So what to expect here is that the value of A, you think that it reveals the elements of the array. It will not. If you run the code, see that A is not equal to an integer. A equals to an address. In fact, this is the address of the first point and the first element of the array. So our array is decayed to a pointer to the first element. This is the address of the number 1 element, which is 1 in this example. And here we have a pointer equals to a pointer, and this is also, so this function gives this function means that array is decayed a pointer to its first element, and this a pointer equals to a pointer. It also reveals the address of first element. Yes. And how about the dereferenced pointer? When we dereference this a pointer, this gives us the value of the first element. So the first element is 1 and the second element is 2. However, here we have the address of the first element. The first element is number 2. The number 1 element is number 2, and the first element is used by 0. So this 0 is first element, just 1. So when we use a pointer, it must gives us the address, the value, because it's reference, the value of the element it is initialized. A pointer was initialized with the address of the first element, and because we have dereferenced a pointer, it gives us the value of the first element. Here we have dereference. So when we run the code, you see here, you see that the reference pointer, a pointer equals to 1. And a pointer and a, they both have the same address. Because our array is decayed to the pointer to its first element, and a pointer is also equal to the address of a, which is of course the address of the first point of the first element. So how can we go to the different elements of this array on the memory? We can go by using arithmetic. Here, if you want to go to the second element, we can use +1, and it gives us the address of the value of the second element. We can go to the address of the second element using pointer, a pointer +1. And now you see that a pointer is not equal to a. Previously, it was equal to this one. Now the value is jumped from 10 to 14 because it is integer, and we have 1 times the size of the integer, which is 4. 1 times 4 is 4, and it now goes to the address of the second element, which is 14. Okay, let's go to the reference. A reference is an alias type which acts as an alternative name for a variable. We have a variable, and a reference is, in fact, an alternative name for that variable. The way we reference a variable is that first we write the data type and then the operator and, such as here integer and then we use R, which stands for the reference with lowercase state, and the name of the variable with the first character written in the uppercase. So here our variable is value, and to write a reference for value, we write integer and or value, and then we initialize with the value. Reference like pointers can be passed to functions as arguments. And functions that operate directly on our variables within the calling functions does not need a return statement. Okay, let's go to the reference example. Here we have a header file called ref.hpp and a source file called main.cpp. In the header file, we include iStream and CMIT, initialize y with 4, y is integer, and then to write a reference for y, we write the same data type, integer, and then write the operator and here we suffix the variable name with R and capitalize the variable name, the first character to be capitalized. So here we have only one character, y, and it is capitalized. And then we initialize with the value of the variable, which is y. Here, in fact, ry stands as an alternative name for y. In the C++ file, we include the reference at HPP, iStream. Then using the namespace std, we execute the functions cout to understand what is the y value and the reference to y value and the pointer to y. Let's go to the Visual Studio. Here I make a new project, empty project, and call it reference project. Here we have header file and source file, call it ref.hpp for header file, and in the source file we write main.cpp. In the header file we include CMIT, we also include iOStream, and for example, we have integer y, and we initialize it with the value of 5. Then we also write a reference for y. So we write the same data type and then use the AND operator. And to indicate that it is a reference, we write R and then capitalize the first character of the variable name, which is y here, and initialize it with y. So we go to explain. Here y is initialized with value 5, and here our y is a reference for y. In the main CPP, we also include ref.hpp, and in the main function, to make life easier, we use namespace std, and in the main function, we write cout directly. And the value of the reference here, it's ry equals to ry inline, and for pointer to y, or ry, can reference it with ry. The pointer to ry, that is we haven't written any definition for pointer, so to write we here write pointer as yptr equals to the address of y. So here so our expectation is that y equals to 5, so it prints 5, and here it prints 5 as well, and here it must give us an address of y. Run the code, and you see here that y is 5, and reference of y is also 5, and pointer to ry equals to an address in the memory. So here ry stands as an alias type, or an alternative name for y. Reference also can be passed to functions or as arguments, same way we did for pointers. Okay, now we go to the comparison of pointers and reference. In summary, pointers can be declared without initialization. Pointers can be reassigned as we did assign value of arrays, we had different elements, and pointer can have different values. We also can the pointer can also contain a null value or zero value. However, the reference should be initialized. It cannot be declared without any initialization. Reference cannot have another value. They can't be reassigned because they are acting as an alternative or alias type for a variable, and reference cannot have a null value. However, the reference is easier to use. Pointers are more complicated. Okay, we are done with the lectures for today, and I hope you understand the topics. And then you do the exercise 5. In the exercise 5, you write a program that a variable points to a double type in the memory. Then you use a function to dereference the pointer variable. Answer the question, is the dereferenced variable the same with the pointed variable? This is the question. And you also write another code where a variable is referenced and initialized with an original variable. So you use the reference, and the reference variable is pointed with a pointer, and then its address is displayed. Furthermore, you add an array of 5 elements in the code, and then you write a code that prints the elements of the array using the pointers. So using pointer arithmetic, you can write the elements of an array on the console. That's all for today. Thank you so much for viewing and being with us. I wish you all best of luck and hope to see you in the Q&A session.